Hi guys, I'm sorry for canceling class today. Got to go to ISTEP testing again. I just wanted to provide a short video for those of you trying to do your 2.4 quiz today. It is optional to do it today. You can hold on to that until Monday if you want. And there will be time in class on Monday to ask for help in general, the way we usually do on Fridays. So I will readjust the class schedule. But for those of you that are really trying to get it done right now, oops, made that too big. So I'm just going to do a quick walkthrough of each question. So number one, on a piece of paper, use a protractor. You don't have to do all that. Draw this triangle with measures of 40, 60, and then they want to know what is the third angle. Draw a triangle here using my handy dandy. And I'm just going to label these 40 and 60. And it wants to know what is the measure of the missing third. Okay, so let's open up 40, 60, missing angle. So we add the two angles we do know. 40 plus 60 is 100. And subtract it from 180. So you'll do 180 minus 100. And it'll give you the measure of the missing angle. That's just an example problem. Okay, let's see here. Question number 2. Sorry. On a piece of paper, use a protractor to construct a triangle with these measures, 20, 30, and then they want to know what kind of triangle this is. So 20 and 30, let's see here. So let's see, 20, 30, and remember there's always 3 angles, so the last one's a question mark. Let's figure out what it is. So we add the two we do know, 20 plus 30, and subtract from 180, so 180 minus 50, 130. So the missing angle is 130. So let's see here, 20, 30, and 130. And your options for this question, they want to know, is this a right triangle? Meaning, is one of these angles a right angle, 90 degrees? Is this an acute triangle? Meaning, are all of these angles acute angles? So that's this kind of triangle. Or is it an obtuse triangle, which means one of these angles is obtuse. And in this case, 130 is obtuse. So as soon as there's one obtuse angle, we call the triangle obtuse. So again, 90 degrees, if there's one of those in the triangle, then it's a right triangle. And that looks like this, with a 90-degree angle in it. If it's all acute angles, like this one, all of them, then it's an acute triangle. And if even one of the angles is obtuse, like the triangle that we just made has one that's obtuse, bigger than 90 degrees, then you call it an obtuse triangle. That goes with number 2. Let's look into number 3. On a piece of paper, use a protractor and a ruler to construct 2 equilateral triangles, one with a side length of 3 and one with a side length of 4. And which of these is true? And it wants to know, let's see, first draw a picture. Not you. So 2 equilateral triangles means that all of the angles are equal. And we can talk more about this on Monday if you're not ready for it. But for those of you trying to do it today, I was just making this quick video. So that means all of these angles are 60. And it says to make the side lengths 3 and 4. So let's do that. This one's 3, this one's 4. And it wants to know what's true about these triangles. Well, these triangles are different sizes. This one has sides of 3, this one has sides of 4. But the angles are all the same, so let's look for that answer. The triangles are the same size and shape. That's not true because they're not the same size. The two triangles are the same size but not the same shape. Well, they are not the same size, so this is not true. The two triangles are the same shape but not the same size. That one sounds correct. It is impossible to construct equilateral triangles with these side lengths. Well, it is possible. So the answer would be this middle one here. They are the same shape, they're similar triangles, but they are not the same size because one of them has a side length of 3 and the other one has a side length of 4. Okay, so that was number 3. This one's number 4. On a piece of paper, use a protractor to construct a right triangle with, I'm going to copy this and paste it here. Hang on. On a piece of paper, use a protractor to construct a right triangle, which means that it's going to have a right angle in it. So, and it has an angle of 90 degrees and one that's 45 degrees. So this is one of our 45, 45, 90 triangles. So I'm going to try to draw it very nicely. So this is the 90-degree angle, and then this is the 45, and it's another 45. And it says what statement is true about this triangle. Oh, and I'm supposed to label these A, B, C. So A is the 90-degree angle, and then B and C. Back for our options. I'm going to snip these. All right, so which one of these statements is true? Is AC 2 inches? Okay, well, AC is the distance between A and C, so is this 2 inches? We're going to use the information they gave us. Up here in the problem, let's use another color, right here. It says that AB is 4 inches, so I'm going to put that here. And remember what we learned about these 45, 45, 90 triangles? Once you know the side of one of the legs, then you know the other one as well, because they're... So is this 2 down here? No, because it has to be the same. So this is not true. It says, is AC 4 inches? So that's still AC down here. And it wants to know, is that 4? Well, yeah, because it's supposed to match. Let's look at the next one. Is BC 4 inches? That's this long distance over here. And no, that's something long. Is BC 8 inches? That's this one over here as well. And no, it's not 8 inches, and also something you wouldn't be able to do yet. All we do at this point is determine the size of the legs, which are these two sides, and they always match. So if one of them is 4, because the problem told us it is, then the other one is 4. Okay. 2. One last one. Copy and paste. Alright, so this one I couldn't take the answer choices off of it, so you can see them already, but that's fine. So it says, on a piece of paper, use a protractor to construct this triangle, ABC, with these angles. And so it will look like... so we have A is 30, that's this one up here. 30. B is 60, that's this one right here. And then C is 90. Notice I keep using a square for 90. That's what people do. Alright, and then it wants to know which one of these is true. So is BC smaller than AC? So is BC on the bottom smaller than AC? You can see visually that it is smaller, so that's why this one's true. And you might really need a protractor to draw this particular one, so we can handle this in class. Is BC bigger than AC? So that's BC again on the bottom. Is that bigger than AC, the one down the side? No, it's not, so not this one. Is BC smaller than AB? So is BC smaller than the very, very long side of AB? And that's true, it is. And then lastly, is BC bigger than AB? BC, is that bigger than AB? This really, really long side? And no, it's not. And the way I'm reading these, so if it says side BC, that just means you start with angle B and you go to angle C, and that's this side. Or if it says side AC, that means you start with angle A and go to angle C. Same with AB. AB, you start with A, you go to B, that's this side over here. Now, if this video was a bit too rushed for you, don't worry, we do have plenty of time on Monday to go over this, but if you just needed a bit of help to get you through the quiz, I'm hoping this will help you for today, Friday. Bye guys, hope to see you on Monday.